Welcome to Ecology Foundations Notes, Part 2. What is food is where we left off. And so, what is food? What do we get from our food? Well, a lot of people say energy. We do extract energy from it, but anyone grow in their lifetime? So, to grow, you have to add building blocks. So, there are building blocks in the food that we eat to grow, repair, develop. And so we get matter. We get matter from our food. So energy and matter are the two components to think about. Using that food to grow, develop, maintain ourselves, and reproduce. So how are energy and matter related? Well, the building blocks of life, or the building blocks of matter on this planet, we have the same amount of Legos on Earth that we've always had on Earth, at least as long as humans have been around. So those building blocks just kept getting reused over and over again. Matter's recycled. Energy, on the other hand, has to be constantly added. It flows one way through living things, stopping temporarily to be part of a living thing, but eventually lost as heat out to the universe. So energy contained by matter allows us to do work. It powers our matter, our bodies, to move, and that movement is kinetic energy. So energy allows us to do work. Matter is the structural building blocks that hold us together, that make us something that has mass. And something that's alive, well, that needs energy. And so matter contains our energy. Stored energy is called potential. So take-home message as far as these two being related: matter gets recycled repeatedly. Energy flows one way through living systems. So eventually all the energy you take in will be lost as heat. If you were to exist even as a decomposed organism, those building blocks would eventually, if you lived infinitely long as a decomposing organism, that energy would be lost as heat. So making food versus eating food. Some organisms make their own food. Some have to take it in. So what's that relationship look like in this picture? Well, the squirrel's eating the walnut. So it is a consumer. There's a fancy name for consumer in your textbook. We'll give that a name here in a sec. The walnut comes from a walnut tree, and a tree makes its own food. It is a producer, making food by photosynthesis. There's a fancy name for producers as well. So the walnut tree is a producer. The squirrel is a consumer. The other name for a producer is an autotroph, and the fancy name for a consumer is heterotroph. And trophy or trophic refers to food. If you think about the first trophies that villagers had in the olden days of human societies, they were successful in their victory if they had a successful hunt, and so they carried back food to the village. So the first trophy wasn't a little plastic statue that you win for a conference title, but rather the successful hunt, bringing back game, bringing back food. So what's the energy source of our producer? That'd be sunlight. Feeding relationship examples. You are familiar with, I think, almost all of these. We have the osprey taking this fish out of the water, predator-prey, so predation. And so if it's killing and eating another animal, it is carnivore. Then you have this moose chewing on leaves, herbivore. And raccoons, well, they like meat, but they also like plants. They eat a little bit both. They're omnivores. So again, terms you are familiar with. Turkey vulture. They're kind of a special kind of meat eater. They look for dead stuff. So we call those scavengers. What about this guy? This little earthworm is breaking down dead plant matter in the soil. So it's considered a decomposer, but a fancy name for some of those decomposers that take pieces of leaves and plant debris, we call them detritivores. Detritivores. But if you said decomposer, you would be kind of right too. This is a star-nosed mole, or no, this is just a regular mole, sorry, living underground, and they feed primarily on insects. So they are a meat eater, but their meat is insects, so they are called insectivores. So we're adding a few new terms maybe. What does this picture model? The producer energy goes into the grasshopper that ate the grass, and the grasshopper gets eaten by the frog. So these arrows are pointing to where the energy is going in this food chain. Food chain. And the ultimate energy source of that food chain comes from the sun, going into the producers. So arrows show us where the energy is going. But this is more realistic. Organisms often, including yourself, feed on many different things. And there's lots of different producers that might feed a lot of different consumers. So this isn't a food chain, but more complex and more realistic. Call it a food web. But it's still showing the different food chains within a community of organisms. What level consumer is the snake? What do you think? It depends on which food chain you follow. It would be second if it's eating the mouse, third if it's eating the kinglet. So what level consumer you are can vary depending on what food chain you're eating within. Where do all the organisms end up? Well, ultimately, every organism dies, and decomposers break them down, and then those building blocks, that matter, can get reused by other organisms like plants, taken up as nutrients from the soil. So matter is recycled. So if matter is continually recycled, what happens to the energy in food? Look at this energy pyramid, and it kind of tells you. As you move up a food chain from producer to primary consumer to secondary consumer to tertiary consumer, what happens to the amount of energy available? It's going down drastically. There is an energy loss with every food chain link. About 90% of the energy is lost in transferring from one level to the next. Only about 10% of the food you eat actually becomes part of you to keep you going. The rest is waste and lost as heat energy. So mostly lost as heat, some locked into unusable waste material. So when you go to the bathroom, a lot of that is waste material that you can't use. Decomposers might be able to. So we call this the 10% rule. And it's why we always have to have more producers than herbivores, more herbivores than carnivores, because of this loss of energy through food chains. So there's always less available energy for top consumers. All right, we're going to stop here. This will be the lead question for our next section, part 3, and we'll pick up with that later.